All right, so now I'm going for molality. Now remember that is moles of solute, so it's still got that same thing as on top of the molarity. So it's still that number up here. And I've calculated this in another problem. If you didn't calculate it in another problem, you'll see in the yellow, it tells me how much solute there is. And then I'm going to convert it into moles using the molar mass that was given in the problem. So that's how many moles. That's how I get the moles on top. 29466 moles of NaCl. Now on the bottom, it needs to be kilograms of solvent. And right now I have a situation where I've got solution and solution stuff. And then over here I have moles of solvent. The way I could get to kilograms of solvent fairly quickly is if I subtract my solution from my solute, and those are both masses. That's going to give me that 67.9 grams of water. And I just need to get that into kilograms because that's what it needs to be in to be a molarity term. And so that is my conversion right there. So I'm going to take that, and that's going to go on the bottom over here. And again, I'll need a parentheses around this whole thing. So I have 2.29466 divided by parentheses 67.9, and then there's a times 1 divided by 1 e to the third. And if you wanted to separate them out, you can, and I left out my decimal. Here we go, 67.9. So that tells me my molarity is 33 point, this had 4 sig figs, but when I subtracted, I kept an extra digit in here. If you subtract these numbers right here like this, that gives you just 2 sig figs in that number. So this just had 2 because it was kind of like rounding to 8. We just kept an extra digit. So that really is going to end up just having 2 sig figs. So it's going to be 34 molarity. Now, again, you would expect kind of the molarity and the molality to be similar-ish. It isn't always that way. But, you know, like on the same kind of a scale. You don't expect one to be like 0.5 and the other to be like 300.